And we are live. So, hi everybody. This is the first meeting of Cloud Native Special Interest Group. As you probably know, Jenkins project has introduced a new initiative in order to have smaller teams working on particular areas. And this team is working on everything related to Cloud Native and especially to pluggable storage. So today we will have a short introductions, and then we will talk about external task logging story. It's one of the foundation stories we defined in 2016 for pluggable storage. So we will start from that, and I hope that then we will have regular meetings to talk about various aspects of Cloud Native Jenkins. So yeah, I guess that's introduction. So maybe we could start from short introductions of people who are on the call. Yeah, I'll share my screen. Okay, do you see my screen now? Yeah, I bet so. So yeah.
Yes, we're in the matrix.
Well, I even have slides. Yeah, so if you want to join the meeting, there is a link to the chat, Jenkins CI/cloud-native-sig in Gitter. If you join this chat, you will see the link, and yeah, feel free to use this chat to post any questions. So we will be monitoring this chat, so you can just ask questions there. And we also have a meeting notes document. It's here. And yeah, in this meeting notes, we will track the entire discussion. So my proposal is to just start from introductions, as I said before. So yeah, probably I should just introduce myself first. Yeah, so my name is Oleg Nenashev. I'm a Jenkins core maintainer. So I do a lot of the stuff on the core side, and previously I used to maintain large-scale instances. So all stories related to Jenkins scalability and reliability are really important to me. That's why I decided to join this special interest group, and that's why I wanted to discuss some projects like external logging in this group. So yeah, that's me. Okay, Jesse?
Sure. I'm Jesse Glick. I'm a longtime Jenkins contributor. Work at CloudBees. And let's see, I've done a lot of work on Jenkins core in different aspects and on the sort of basic infrastructure for Jenkins pipeline build system. And for a while now, I've been working with Oleg and Carlos on scalability of Jenkins storage. So, for example, the external artifact storage.
Thanks, Jesse. So let's start from the left. Alex?
Hi, I'm Alex Nordlund. I work in DevOps at Cinnober, and I'm interested in scaling Jenkins and getting things externalized to SQL.
We had a discussion with Alex about configuration storages, so it's also one of the stories which we will be discussing at the next meetings. Okay, I lost the chat again. So, Liam?
Yeah, hi. Just turn my video for a minute. Hello, I'm Liam Newman. I work at CloudBees. I'm a Jenkins technical evangelist, longtime DevOps, well, not DevOps, CI/CD advocate, and interested in scaling Jenkins, definitely. I've mostly worked with, I've seen those sort of the limitations of what one Jenkins master can do on its own. I'm interested to see where we can go if we remove some of those limitations.
Okay. Rick? Yeah, by the way, this document is editable to everybody, so you can just edit self-description. Okay. Sorry for interruption.
Okay. Hello. I'm Rick, and I'm working on a DevOps project in China company, and we expect find a way to get a log in a more beautiful way. Yes, thank you.
Yeah. Just please feel free to edit this chat. Yeah. So, whom else do we have on the call? Carlos? Yeah.
Hi, this is Carlos Sanchez. I'm working with Oleg and Jesse on externalization of the data on Jenkins. I've been contributing to Jenkins for some years now, and I guess I'm the chair of this SIG, so we'll see more of me in the future.
Yeah, right. Then, yeah. Oh, we've got so many people on the call. Evelina?
Hey, I'm a continuous integration, continuous delivery consultant in Pragma, a Scandinavian-based company. And currently I'm working on Jenkins configuration as code plugin. We were actually considering having a separate group for that one, but we've decided to check if it maybe makes more sense to be a member of Cloud Native group. So let's see how that goes.
Yeah, it's still my action item to raise this discussion. Okay, thank you. Yeah, Tracy?
Hi, this is Tracy. I'm Director of Open Source Community at CloudBees, and yeah, just generally looking forward to Jenkins going more cloud native.
Vic?
I'm Vic. I'm Vic Iglesias. I work at Google Cloud, and I've been using Jenkins for a long time, and I've been evangelizing, best practices for Jenkins on GCP for a few years now. I do a lot of the publishing of articles and tutorials on our site, and externalizing that through conferences and things like that. So I'm just here to make sure that Google can plug into all these cloud native things that are happening.
Mm-hmm. Yeah, thank you. Yeah, I'm really making notes, so yeah, please feel free to edit. And yeah, whom else do we have on the call? Jeff.
Hi, my name's Jeff Pierce. I'm a development manager at GoDaddy, and we're in the process of moving our stuff from OpenStack to AWS, and so we're interested in moving our Jenkins cluster as well. I've been a plugin developer for about a year, so I'm also interested in contributing if it makes sense.
Mm-hmm. Yeah. Thanks everybody for introductions. Have I missed anybody? Oh, just a second. I'll paste link to the chat. Okay. Yeah, the link is pasted. Okay. So yeah, let's go back to the SIG introduction. Actually, I already said some bits, but yeah, generally, if you want to know more about SIG, you can find information using the links on the slides. So yeah, as you may have seen, we have a Gitter chat. We also have a mailing list where you can find all the ongoing discussions. So it's Jenkins-cloud-native-sig, and yeah, there some threads already, and it's just a first meeting, so I hope that we will get more and more discussions here. Then what else we have? Actually, we have some discussions in the developer mailing list, and recently I've also posted my vision about what cloud-native-sig would do. So today we've heard some inputs and interests from SIG participants. And if you want to contribute your vision, and if you want to weigh in on what you would like to see being delivered in cloud-native-sig, just respond to this thread, cloud-native-sig vision and priorities. So let's have a discussion there. So what do we do today? Today we do, today we have pluggable storage discussions in general and external logging overview. And then we will be able to discuss all other stories we may want to cover at the next meetings. So as you've seen, we have submitted an find major things, and you may see that there is a number of existing JEPs. Several ones are related to external logging. So firstly, it's UTF-8 use for pipeline builds. So then there is external build logging in Jenkins core, one pending JEP for external logging API, and then external log storage for pipeline. So all these things are linked in the mailing list, I've already got some feedback from SIG participants, so I assume that you know what is the context of these JEPs. But I'm going to just make a really short introduction before we deep dive into the discussion. So if you have any questions, again, please use Gito. Okay, pluggable storage. So this story may mean different things for everybody, but generally it's well known that Jenkins stores pretty much everything in Jenkins home. So it means that it stores logs, configurations, all kinds of metadata there. This Jenkins home is generally a location on the machine hosting Jenkins master. Of course, you can connect NFS and externalize it in such way. But it's still a well-known scalability and performance bottleneck, because big storage means big loading time sometimes. Sometimes this data just cannot be externalized. Sometimes it's not trivial to do the backup. So there were many concerns about these storages, and there are many proposals. Actually, there are also many plugins. For example, for Artifact Manager, there are plugins like Artifactory plugin, OS3 plugin, which allowed externalizing artifacts using custom steps. Same for logging. There is a Logstash plugin, which also allows externalizing log. But the problem was that all these features were implemented in plugins. Sometimes they were implemented using various hacks and workarounds, and it was pretty difficult to configure the instance and to use that. Even if some stories can be addressed, it's still a big problem, because from Jenkins architecture standpoint, we cannot easily implement these things. So plugin developers spend a lot of time. Sometimes they hit issues with missing extensibility. So, for example, Alex had an issue with XML storage when he wanted to externalize it to SQL storage. Probably he discovered that XML file is just hard-coded as file within Jenkins APIs. So it would be hard to externalize that. So all kinds of these problems are in the scope for pluggable storage. And actually, pluggable storage may include multiple instances. So it may be artifacts, build logs, configurations, etc., etc. 2 years ago, we had a contributor summit when we spent maybe 3 hours and a lot of time after the discussion to talk about these stories, to prioritize them somehow. It was 2 years ago, so I don't think that these priorities are still relevant. So in this SIG, I would rather expect the team to define new priorities. Okay, the story we will talk today is build logging. Just to check, did everybody take a look at the designs and the proposals? So if you haven't taken a look, just tell it. So I will probably spend more time describing how it works. Hello?
I think that means everyone's willing to continue on, unless people are muted and.
Yeah. I think it'd be cool to just see an overall overview of what the design is.
Okay.
Maybe not a deep dive, but just the integration points, maybe.
Mm-hmm. Okay, let's do that. So yeah, for build logging at scale, there are two major problems. So first one is that all logs go through master. So what does it mean? That if your agent produces a build log, for example, 1 gigabyte or so, what it does, firstly, it streams the entire log to the master. Then master saves it to the disk. And yeah, if it's one agent, it's fine. If you have hundreds of agents, it means that at every time you may have pretty high network traffic, you may have pretty high traffic to the disk, and moreover, you can have a pretty big RAM and CPU overhead because you need to buffer these logs, you need to process them. There is remoting protocols involved which send all this data. So effectively, it hits all the resources. And one of the biggest problems is that Jenkins itself doesn't prioritize traffic. So it means that if you send gigabytes of logs from agents, some system traffic may get lost, and it may lead to the instability of the entire agent ecosystem. And we hit it multiple times before. Another problem is with browsing of logs, because when users browse the log, they may go to the console. Each time Jenkins master has to load this log in order to display them. And probably you've hit the situation when your users forgot about closing browser pages. And then there were hundreds of browser pages, browsing logs, and yeah, each of these browser page consumes some master resources, and eventually even such browsing may hit the stability of the system. So, for example, we had a case when we had a network disconnect in our office. People had open browser pages. At this point, these pages had automatic reload. And yeah, when the network restored, we had something like a few dozen log browsing sessions, pulling in all logs, and it completely it may just cost DOS on the master side. So these issues are well known. Actually, we were discussing it in 2016. In 2016, there were lots of discussions, and yeah, the idea was that instead of sending all logs to the disk, we would rather send them to external storage and display them from external storage. So you may see some arrows there. So the main idea is that nothing goes to the disk, and then master and agents send logs directly to the storage. So there is no extra traffic between master and agent. And then ideally, agent users will be able to browse the logs directly from console without utilizing master. So, for example, we could implement some thing which would use JavaScript in order to retrieve the information on the client side and just display that. So it was the idea. In 2016, we prototyped that. So you may see that there is just a screenshot of my presentation with demos. I will show this demo later if you're interested. But yeah, the idea is trivial. So in 2016, we created some prototypes for Elasticsearch. So there were several contributors, and in 2018, this winter and then in spring, we revised these stories. We refactored some pipeline storage. So there is a lot of pull requests created by Jesse. And finally, we created a new demo so that it's something you could try if you're interested. So this demo is packaged as Docker Compose. You can just run that. And this demo allows to do some external logging using Elasticsearch. So yeah, I'll probably show it later. I just click make run. Maybe I should just show it. Okay. Yeah, I'll show it later then. I was switching between the demos and I have similar container names.
And by the way, Oleg, I have
Yep.
I have a demo of the pipeline side of stuff with CloudWatch ready for any time. If you...
Okay, then we can just demo CloudWatch, and then I can demo Elasticsearch if somebody is interested. Okay, so regarding the JEPs, the current vision is that we have a logging system. This logging system will be generally based on the external logging API plugin. So it's just a top-level plugin which offers high-level interfaces and plugin implementations can extend this API and extension points in order to log and to send logs and to browse them. So we expect the most of the complexity to be based around here. And yeah, we still need to do some bits on the core side, because currently you cannot easily do external logging for freestyle projects. In 2016, we have created an implementation based on the Logstash plugin, and we were able to work around the most of the issues in Jenkins core, but it was a kind of weird hack. And instead of that, it would be rather preferable to have pure implementation in Jenkins core with extra APIs added. So, for example, it would be possible to define a logging method and log browsers for runs, and then all APIs would be handling that. In addition, there are pipeline patches. Probably these pipeline patches will, most likely these pipeline patches will be much more complex than Jenkins core patches themselves. So the idea that a durable task has a different implementation, and in order to utilize external logging in pipeline durable task, you need something different. So Jesse will talk briefly how it's implemented later. But yeah, generally for pipeline, it's possible to create external logging engine without utilizing Jenkins core at all. So it's not clear how these stories will interact between each other, because currently we have independent implementation for JEP 2.0, which doesn't utilize Jenkins core patches, and we have Jenkins core patches, which also provide some overlapping API. But the good thing is that this complexity is hidden by external logging API plugin. So it just offers bridge methods for pipeline, and then final implementations do not need to care about that. So yeah, this is a current vision of how it would work. And yeah, this is how we implemented the JEPs.
And let me just jump in here real quickly. The links to these JEPs are posted in the chat and also in the notes for the meeting.
Yeah, they're
if anyone's interested. Yeah. So we can come back with, if you're looking for, you're wondering how to get those, they're in the docs and also in the chat.
Yeah, thanks, Liam. So in addition to that, we have some related JEPs. As I mentioned, UTF-8 logging for pipeline. And there is open discussion about whether we want to have UTF-8 in the Jenkins core. So let's talk about it later. Okay, regarding the implementations, currently we plan 3 base implementations. So one is file system-based storage for Jenkins core. So this implementation is just what we have now. exactly in the same behavior. So logs are streamed through the master, logs are stored on the file system, and this compatibility thing is required so that nobody notices changes when they update Jenkins to the version with new APIs. And then we have 2 reference implementations in prototypes. So one is based on Elasticsearch. This implementation is a generic one, so you can run it in the cloud or in a classic setup. It doesn't require a specific environment, and yeah, it's fully available now. It's hosted on the Jenkins side. And another implementation is being implemented by Jesse for FluentD and CloudWatch. It's also available now. It's AWS native, so it's actually AWS CloudWatch. So the idea that we show cloud native implementation, which is highly efficient for a particular service, and some AWS focused projects, for example, Jenkins Essentials, could use this implementation and get benefits from that. So these are the current reference implementations we plan. And if you are interested to implement something else, let's discuss that at the call.
I have a question on the FluentD and CloudWatch plugin. Is it possible to build off of the FluentD setup there to do other providers with just FluentD? I know that most things can run through FluentD, like even Elasticsearch and Stackdriver and a bunch of other things can be configured there.
Yeah, that's possible.
Actually, I guess I could take that. At least in the current prototype, the FluentD specific code is so short, it's pretty much irrelevant. Actually, most of the complexity is in the CloudWatch side, plus the underlying changes to pipeline logging and so on. But yeah, I mean, if you needed to have, yeah, I mean, somehow or another, you need to have some way for Jenkins to send data and some way for it to receive data if and when required. And the sending side in this case is pretty simple.
Yeah, right.
Cool. And then a question on the viewing side. How is authentication, is the idea already to be kind of browser specific JS to pull the data? And how would authentication work for each user?
That's currently handled in the Jenkins master. That might be clearer if we do a demo of that. So maybe we might want to hold off on that sort of question until after we have a
maybe I should just so we have JEP 207, and the story is explicitly covered there. So client side only log browsing. So we had some demo implementations for Kibana in the case of Elasticsearch, and Jesse also has implementation for CloudWatch. But in the scope of the current JEPs, we decided to put this question aside. So it's possible, but we do not add specific APIs for that. But yeah, we can talk how it's implemented, and it's pretty trivial. So in the current reference implementations for both, for both Elasticsearch and FluentD, we wrote log browsing through master for now.
Doesn't have an option to ingest and we looked at options from FluentD to ingest the data from the backend, but then you need to query the backend in a specific way. So whenever you're browsing a job, you want to see the logs for just that job, and do things like that FluentD doesn't allow. FluentD is more like just streaming everything, so there's no easy way to use it for consuming data. You have to go to the backend.
Yeah, right. So speaking of the entity design, so what I did in the design is that I defined separate abstraction layers for logging method and log browsing method. So it means that, for example, if you know that you sent the log to Logstash but browse for Elasticsearch or something like that, you can explicitly define different logging method and browsing method, and it would be working. So technically, we can create more than one log browsing implementation depending on what backend storage you use. It's included in the design now, and yeah, it's how it would be working. Okay, so since I've already presented this slide, so this is how the current demo for Elasticsearch implemented. So we have Elasticsearch external logging plugin. It has one implementation for logging, one implementation for log browsing. Previously, as I said, we had implementation for Kibana, but for now I removed it. Maybe I will restore that depending if time allows. Originally, this implementation was based on the Logstash plugin, but in the current version, I removed this dependency because Logstash plugin has some issues. For example, JEP 200, there are also some missing public APIs, so the plugin would need a patch. And for the reference implementation, I decided to have a clean engine. This plugin depends on external built logging API, which implements all the stuff. So these implementations are really small. They just query the data and send it back using common interfaces. And external logging API does the main job. So yeah, everything in there, and later I can show you the code. So yeah, it's pretty simple. Regarding CloudWatch and FluidD, the approach is pretty similar. The current draft doesn't use external logging API because yeah, it has been created as a reference implementation for pipeline log storage. But yeah, I think that for the final implementation, we would be rather start using external built logging API as well, especially if you want to support freestyle projects. Okay, so these are two implementations. Current state that all JEPs are submitted. 3 JEPs have been already accepted as draft. 1 JEP is approved. So I guess the only thing left here is to just integrate it.
Yeah, I just haven't. I'm actually working on that right as we speak. It's getting that number.
Okay, thank you. So yeah, all these JEPs ready to go. We have started some discussions in the mailing list. I think we will need more discussions because yeah, there are some design edge cases. And yeah, regarding reference implementations, we have 2. Core API and file system storage is ready for review. So it's here, Jenkins CI, Jenkins pools. So yeah, here's this thing. So I hope that we could integrate it as beta API shortly, so that we can start evaluating the plugins. But yeah, it's something to be discussed. Regarding the rest, yeah, all other things are also published and ready for review. So for example, external logging API. Second, so external logging API is here. It's the build is not passing. I need to pass to fix something, but yeah, it's here, so you can take a look how it works, and it starts. It has some integrated mock tests, and finally we have a Logstash plugin. So it's also ready. It's here. You may see that the code is pretty big now, but just to clarify, this code includes all kinds of integration tests, demos, etc. And some bits still need to be moved to external logging API. So for example, we define an extra JSON convenience layer because yeah, many common external logging implementations use JSON. So it would be rather reasonable to have it an external logging API. And yeah, these things still need to be moved. But yeah, this demo basically started working, and yeah, I'm pretty confident about that. Regarding pipeline storage, we also have everything in place and pending reviews. I forgot to paste the link here, but yeah, as Jesse said, everything is linked from the JEP. So here's JEP 2.10. You go here. And here you can see a number of implementations. So you may see that durable task is patched, a number of pipeline plugins, and yeah, here's a link to the reference implementation. Okay, so just regarding the design in general, I think it makes sense to discuss these questions once we finish with demos. So one of the questions submitted by Alex was about multi-destination logging, where we can send logs to multiple destinations at once. Then we have a pending question about switching abstract project builds to UTF-8, whether it makes sense, whether we are ready to invest into that. Then we have open concern from JC about events API. So the current state is that Jenkins mostly uses data streaming APIs in all its implementations, and introducing events entity may increase the complexity of the implementation. So my current design introduces events at the level of external logging API. So they do not exist at the Jenkins core level, but for all external logging implementations, I expect these events to be implemented. So it may be something complicated. Then we need to understand whether we need a different logging method and log storage entries, because yeah, it's one of the difference between reference implementations. So my implementation in the core introduces different abstraction layers. JC's implementation in pipeline has a single log storage extension point, which does both. And yeah, it depends how we ensure the complexity, etc. And yeah, final question I noted is about depending on external plugins, because what I needed to do is to depend on unique ID plugin. So the story behind it that in Jenkins project, in Jenkins you can rename the jobs, etc. And when you rename the jobs, you need to ensure that the logs are still somehow accessible. So in Jenkins, there is a plugin which allows assigning unique IDs to jobs, etc. And I used this plugin in order to inject unique identifiers for jobs and bills. But yeah, it's still an external dependency, and it's a design concern which we could discuss. So these are questions from me, which I propose discussing. But yeah, I think we could take a look at them after short demos. What do you think?
Yeah, let's do the demos first.
Okay.
The discussion will take a little bit longer, I think. So.
Yeah, right. So yeah, then I'll let Jesse present his Fluentd CloudWatch implementation, sure. And then yeah, regarding Elasticsearch one, it's a pretty boring demo because it just works, but with Elasticsearch. Okay, so yeah, let's start from Jesse's demo.
Nope, nope. Okay. Let's get to this one. You should be able to see this. Yep.
Yeah, looks good.
Great. Okay, so this is an implementation of external storage of pipeline build logs in CloudWatch. And the code perspective, it's a single plugin, as you can see, but it has a number of dependencies on various patches to parts of pipeline. So here's workflow API plugin, workflow job plugin, durable task step, and support plugin. So there are several pipeline core plugins that have been patched for this. If you're not familiar with this version number notation, these are called incremental versions. Basically, the idea here is that we're able to put together prototypes like this where every time anybody pushes a commit to a pull request that passes CI, you automatically get a publicly usable quasi-release of that plugin that you can depend on. So that makes it easy to play around with experimental APIs like we've put together even before they've gotten merged by plugin maintainers. And the and basically it just adds one extension point, which in a nutshell allows us, it says that whenever you have some build log messages coming out of a pipeline build, then they should go to this Fluent dlogger, which as I was mentioning before is pretty dumb simple. It's basically just creating this output stream that says whenever you get a complete line of text, then put together this little JSON record with information about the build number, which pipeline step sort of it's running, and a couple other bits of metadata. And then this is just going to some library called Fluency that sends to Fluenty. And that's basically all it does. So as you can see, it's quite short. And then if and when somebody tries to browse build logs from Jenkins, which might never happen because they might just be, getting a green check mark in GitHub or something and never pay attention. But if they do, then we make some API calls directly using CloudWatch logs API. So this is coming from the AWS SDK. And this part is a little bit more complicated because we need to, the meat of it is that we need to create a filter query in CloudWatch logs that looks up a given log stream, and then it does some query patterns to pull out particular fields in the JSON. And then it takes all of these log messages and packs them together into basically a plain text stream in a format that Jenkins core is comfortable parsing and rendering as HTML. So if we go to an example completed build here. So here I've got a pipeline build that's run in a couple branches. Part of JEP 210 is that is some minor enhancements to the classic UI log view, which is especially helpful for showing demos. So you can see which parts of log output are coming from different branches or even individual steps and things like that. So we have some messages coming from this branch that are running locally on my laptop, and it's running some shell scripts and stuff like that. And then we also have another branch that's running on a make-believe agent. So it's still physically on the same machine, but I'm using remoting protocol. So it's running in a different Java virtual machine for the controls. And then it's, again, running a shell step. And I'm doing things like using the with credentials step to do some stuff with passwords. And you can see that the passwords are getting masked and running some other stuff that takes a little time. So we can, if you want, we can run a fresh build, and you can see that we're going to get, this is a little bit slow because I'm running Jenkins in development mode, so everything is artificially slowed down here. But if you go to console output, so you can see that we're getting some live console output. And so there's a shell process that's running, and it's continually streaming output directly from that agent to Fluenty. And then Fluenty is collecting log messages and sending them onto CloudWatch logs. And then Jenkins master is polling CloudWatch logs and asking for new events that it can display in this. And so then it's showing an incremental log display. And if you want to, yep.
Maybe you're about to say this, but I was going to ask, so for this demo, did you write these both as one plugin, or are they two separate things? Or
this is one plugin.
Okay.
Yep, they handle both sides of it. As I said, the Fluenty side of it was pretty minimal, and a lot of the details are actually sort of communicating in between. The exact format that Fluenty is sending has to exactly match the format that will appear in CloudWatch logs.
So I'm just figuring though in a non-demo state, sort of what Vic was asking earlier. So having the thing that sends the logs as one plugin, having whatever storage backend that you want would probably be two separate plugins.
If we have external logging API, it would be possible. Because, yeah, as Jesse said, sending logs and reading logs is interdependent because you need to define how to store fields, etc. But in external logging API, we have a JSON layer, and this JSON layer unifies that. So for thin implementations, you can just make them completely separate, and then they will be working using the same API.
Right. So somehow or another, you need to make sure that the particular choice of fields and their format and so on is lined up between the sender and the receiver. In this case, it's all just within a plugin, but in Oleg's prototype, it's that common format is defined in an API plugin instead.
Got it. Okay.
So, and this also partially for demo purposes, possibly useful. It also adds a sidebar link that jumps directly to the AWS console. So let's see if this opens up. Yep. Okay. So this was my build number 50, which is now completed. So it's constructed a query in CloudWatch that's going to a particular log stream, which is named after the job. So if you have some multi-branch project within a folder or whatever, you'll get a corresponding log group name here that's just based on the full path in Jenkins. And then it picks out all records with that build number so that it filters it to only this particular build of the job. As you can see, let's get rid of the time because it's just taking up some space that we don't really need to have there. It's a little bit better. So as you can see, the plain text of each line is sent in a message field in the JSON. Currently, we're recording a timestamp separately to work around a bug in one of the Fluenty plugins. This would probably go away, and we would instead use the source timestamp that's defined by Fluenty and also honored by CloudWatch to keep track of the order of events. You may have noticed that there are classic Jenkins UI annotations in here. So you see certain things like stuff that's in gray because it's part of the metadata of the build, and you also see some things like hyperlinks, which work like they would in any Jenkins installation. So those are all separated from the message so that we could build log viewers that just show the plain text. And then the particular, I'll expand this, you can see a little bit more detail. The actual data that's parsable essentially only by Jenkins is kept in a separate field in the JSON. You can't really do anything with this outside of Jenkins very easily because it's base 64 not encrypted, but cryptographically signed version of a serialized Java object that tells it what HTML to render there. So that's
but the good thing that if you browse logs outside of Jenkins, you can get the raw text at least.
right. Yeah. So the raw text is available as a separate JSON field. So if we do build an external JavaScript client that somehow gets an API token suitable for accessing CloudWatch directly, then we could just pull out this message field and ignore the annotations. It does record the build number, as I said before. Node is a reference to which particular pipeline step this came from. So if you go to the pipeline steps view in Jenkins, let's see, up, yeah. So that was the line that said, This was a node block. It said running on remote or something like that. So branch node, yeah. So this log message here, as you can, if you can see the URL here, this 8 is the representation in pipeline of which step it was running, and this single line of text is basically produced by doing a CloudWatch query that says shell.node equals 8, I think, if you do. Maybe it's a ampersand or something. Yeah, there it is. So basically, when you display this page, and the same would be true of Blue Ocean. I haven't loaded that up in this demo, but when Blue Ocean is showing you per step log output, it's making essentially the same query and only loading those messages from Fluentd. All of this, if you go to the build record on Jenkins, you see that there is no log file in Jenkins. So we have other kinds of Jenkins-specific metadata are still being stored because we haven't worked on those things yet, but there is nothing stored on Jenkins Home that contains any of this log data. It's all in CloudWatch. And another thing you can see is that we're doing some password masking here. So if you go take a brief look at the pipeline that it ran, or you could use a replay link. So I'm using the with credentials step to do some password masking. And this is inside an agent node block. So this is supposed to be running remotely, not in the Jenkins master. That password masking is still effective. So even though the shell script actually printed receiving and then some secret text, it got replaced by asterisks. And that you can also, back to the overall query, you can see this somewhere. Yeah, you can see that this is in fact masked out on the CloudWatch side. So before the message was sent to Fluentd, the password masking was done. And that was actually done on the agent side. Something else that's done in this reference implementation is we're defining the sender field. And this is pretty important because this goes to one of the key performance aspects of the whole system is that this write replace method, this is Java serialization, and it's called when we're sending a handle to the Fluentd log output over the remoting channel to the agent side. And when we do that, we're keeping track of the fact that this is a different instance, a different Java virtual machine. And every time we send a message, we're recording that in the log record. And so you can see some things that are running, say, from a shell step in the master, or say that they're sent from the master node. But when we got this, we saw that it was sent on the remote node. And that meant that this log message and all of the work, all of the use of the Fluency logging library was done entirely on the agent side. So we never transferred this text or anything related to it back to the Jenkins master. The master will only ever see it if we display the UI for it.
Yeah, and technically it works for almost every console log filter. So it's a standard extension point in Jenkins core. So if this log filter is serializable, it can be executed on the agent side.
Right. So essentially, this is this is part of one of the patches that was done in pipeline code. Is that we have basically a fresh set of code that's implemented for sending log messages from pipeline steps, and it produces something that can be safely transferred over a remoting channel. And among other things that it does, it assumes that the task listener is something that can be safely transferred. So in the case of the Fluenty implementation, that is, this Fluenty logger object is serializable, so it's safe to transfer. And we also check that any console log filters, like the one that masks passwords, is also serialized and sent over to the agent side, so that basically the agent becomes autonomous. It can just sit there and handle 300 megabytes of output and send it right onto Fluenty without any communication with the master after the steps.
One of the things we should be aware here, so we check only that it's serializable. We don't check that it actually can be serialized, because Jenkins has its own stuff like JEP 200 deserialization protection. And yeah, you probably should ensure that whatever we send, if it's rejected by JEP 200, it doesn't break the rest of the logging.
Well, JEP 200 won't apply here because we're sending something from the master to the agent. There could be cases where something is marked serializable, but it's really only expecting to be serialized in a different context.
It's another story.
Yeah, yeah, we probably will at some point need further APIs for, or at least do some functional tests or something like that to check if there are problems with existing console log filters. But
yeah, right.
At least for with credentials step, it worked without modifications to that plugin.
Also for mask passwords and some other bits. But yeah, there are so many things which rely on this functionality. And in the JEP 207 design, we presume that some compatibility may be broken, and it's explicitly written in the design. So we will be tracking these issues and documenting them like we did for JEP 200 before.
Yep. I think that's all of the important parts of the demo. If anybody wants to ask questions about what I just showed, if you haven't already written anything up, I don't see anything in the chat. But
I don't see any questions in the chat or anything else. Anyone on mute that's asking questions? Okay, good. Just checking.
Okay.
It's really cool, Jesse. I'm really eager to see where that goes.
Yeah, right. So we have 30 minutes left. So what we could do, we could briefly discuss the design concerns, or I could show the external logging KPI part. Yeah, but from the behavior, everything is expected to work pretty much as Jesse has presented. But instead of doing it on the custom implementation side, you just should get a pretty simple API which you implement, and everything starts magically working, because the rest is handled by external logging API plugin and Jenkins core.
So instead of having to create your own message format, the API will specify that.
Yeah, right. So I can briefly show it to you.
Yeah, sure. Let's just take a quick look.
Okay, so do you see my screen?
Yes.
I should point out that creating a message format is literally a few lines, a few minutes.
Oh yeah. But if we have have a consistent one across all of them, then that sort of.
Yeah, right. So when I said message format, it's not only about the event. So you may see that the event is pretty simple. It's just message timestamp and whatever ID. But yeah, we still need to send additional metadata, and this metadata depends on the log type. So although in the design we do only build logging, we keep in mind that eventually we will need logging for other types of events. For example, agent connection or multi-branch repository scanning or whatever. So the implementation in JEP 207 is a bit more generic. So in addition to that, we need console annotations which should be injected. And yeah, even this data is being generated automatically. So what we expect from the final implementation? The final implementation actually should implement only one method. It should produce external logging writer. So yeah, here. And you may see that the publicly accessible method, when you create a writer, it also injects some metadata, for example, build number, job ID, which we need to retrieve the data. And yeah, if an implementation creates this method, everything starts working out of the box. And this method in the current implementation is actually just a write event. So whatever you need to do, you just write this event, and it's up to you how you handle that. There will be an additional abstraction layer for JSON events. So finally, it will be simple. And of course, this logic will be doing all things like processing streams, because one of the complex parts is that you need to process incoming streams. So, for example, currently it's in Elasticsearch plugin, but it will be moved. Yeah, what you do is that you sit on the output stream. You receive the stream, but you need to parse it, and then you need to extract console nodes, put it somewhere else. So these implementations will need additional logic, which I'm trying to put externally so that you get better API layers. And finally, yeah, so how it looks like. So currently, this is a write event for Elasticsearch. So effectively, I get event and convert it to JSON, which I sent to Elasticsearch. But this code will be also moved to external logging API. So effectively, you will just need to implement a push method, which puts the data externally. Obviously, for Elasticsearch, it may be a bit more complex finally, because you need to handle indexes, especially if you want things like index rotation. But from event sending part, it should be still simple, and same for browsing. So this is all the idea of external logging API stuff. And yeah, if we switch back, so you may see that there is a bridge method for pipeline. So external logging API implements pipeline log storage. So it means that the current implementation can work with both freestyle projects and pipeline. And this bridge method should ensure that it's transparent to the user. So at some point, when, for example, pipeline implements new Jenkins core APIs, this implementation can be just replaced, and everything will continue working transparently. Okay, so yeah, that's the idea. So this is a big class which integrates almost everything, which adds all these convenience layers. It also introduces extension points so that it becomes configurable from the user standpoint. So for example, there is external log browser factory, same for logging method. So finally, you would be configuring them either from UI or from configuration as code plugin. So how it looks like. Actually, I haven't converted my demo to configuration as code yet, but yeah, he's a number of Groovy hook initialization scripts. So here what I do is that I set up what would be logging method and browsing method for my instance, and it's applied globally. If you need something more complex, you can create another factory implementation which would take into account, for example, folders, or which would be merging several logging methods as Alex proposed. So all these things are possible, but yeah, it would require a bit more complex configuration than I create now in the reference implementation. Okay. Yep.
Yeah, I mean, I want to point out that at least in the JEP 210 reference implementation, I mean, the actual sources of complexity and bugs, including one I just fixed today, are mostly surround the particular mechanics of the log browsing. I'm not sure if I want to go into huge amount of detail, but basically, I mean, if you look at the current implementation, it's fairly complicated to figure out exactly how to get exactly the right events from CloudWatch efficiently and to pick the particular point when you're doing incremental log browsing, because all of the Jenkins APIs are oriented entirely around plain text output streams, with sort of a notion of a assumption that things are being stored in a binary file. And so you have to do a fair amount of work to basically fake that out and produce equivalent behavior without that. And we'll probably need to do some fundamental changes in core to the code that displays logs, and in Blue Ocean plugin as well, to allow plugins like this to do something more efficiently. For example, currently we're just taking all of, like we have this
here
unfortunate loop where we basically just have to get all of the log records for a given build, and we basically can't pay any attention to the byte offset that Jenkins passes us, because that concept doesn't line up at all with what CloudWatch provides. So I mean, CloudWatch provides pagination, and it provides a token system so that you can retrieve log messages by page, but we have no way of hooking that into what Jenkins actually does.
Right. I have a pretty same problem. So you may see that I pass offset, but at some point this offset magically disappears, because we cannot do much with that in Elasticsearch as well. And another problem which hits us hard is eventual consistency. So since we report logs in parallel with agents and from the master, especially in pipeline, we do not really know what is the order. So API things like scenes just do not make sense, because when a large text pulls in logs once, it doesn't guarantee that there will be no events posted for earlier timeframes after we query the data. Because in Elasticsearch, it may take a few seconds before everything is synchronized on a cluster. In Fluentd and CloudWatch, it's pretty much the same, because we push the data to Fluentd, then it takes a while till it flushes the buffer to CloudWatch. So I guess eventual consistency presence there as well. So
so for CloudWatch, it's we are able to handle that, but it requires special code that we need to go back and double check with CloudWatch whether it's actually received a given event that we had sent to Fluentd earlier, and if not, we need to instruct Jenkins that we don't yet have a complete build log and that it should keep on.
Yeah, right. I started implementing this API as well. So most likely the eventual consistency engine will go to external logging API plugin as well. Because I found no good way excepting doing pretty same thing like JC does.
Yeah. And to some extent, this is implementation specific. So in the case of Fluentd CloudWatch, we actually would want to, currently it's using a JSON field, but we would actually want to use the native timestamp field for the record as soon as that has millisecond precision.
Yeah, there is a question whether millisecond precision is actually enough for logging. Because milliseconds in Java are not really milliseconds, especially on the distributed instance. So
there can be clock skew between master and agent.
So it's something we will need to consider eventually, but there is no good solution. So the only thing that it happens in such way, even now, we just put everything to this single stream, so we never notice it.
Right. Yeah. So for now, for CloudWatch, I'm simply sorting everything by source timestamp under the assumption that the clocks are reasonably close, and so you get a build log that shows an interleaved view according to source clock, basically.
Mm-hmm. Yeah, right. So yeah, as you may see, there are some issues behind we are trying to solve. Yeah, that's why I originally decided to do external logging API. So we do not bring all this stuff into the Jenkins core, and then that we keep it as simple as possible. Okay. So what do you think about such approach? Okay.
And I think it sounds pretty cool and very useful.
I think you had a question earlier about code coverage and test results. Was that you?
Yeah, it was Jeff.
Yeah. So that's actually being tracked as separate efforts. Jenkins has a very different system for managing things like test results and code coverage. That's also certainly something we're interested in. I've already started some research and bits of experimentation with test results. But that's not going to look anything like this, and we would likely not be using the same backend at all.
Well, we may be using the same backend eventually, but whatever we do will be pluggable. So it means that if somebody wants to implement, for example, SQL-based storage, it will be possible.
Right.
And yeah, speaking of code coverage, yeah, together with Jeff and Shenyu and several other mentors, we are working on a code coverage API plugin, which introduces a kind of unified data model for code coverage plugins. So it would be the first foundation step to externalize this data, because our current problem is that each plugin implements the storage on its own. So, for example, it's not even always XML. Jacoco plugin uses non-XML format. So we wouldn't be able to use XML storage abstraction layer proposed by Alex. And yeah, it's a major issue on this front. But once we have once we have a code coverage API plugin, it's something which would be plausible. But yeah, it's not even designed. So it's just somewhere in the list since 2016. Okay, just a second, I'll show the entire list of stories we had on the table. Okay, so back to my slides before I lost that. Yeah. So yeah, we have several data types, and yeah, there are test results, but yeah, obviously test coverage would be somewhere around here as well, because yeah, coverage is also a part of the test data usually. Okay, any other questions? Not in the conversation history.
Yeah.
Actually, I have a question, not really technical, and I'm sorry if you already mentioned that, I just did not get it. So what's the maturity of the things you're presenting? Is this released? Will it be released in a predictable future?
These are JET drafts at this point. They're just starting that stage, okay. Right?
Yeah, right. So for pipeline storage, everything is available through incremental releases. So if you want to just try it out, you can use existing tooling like Docker, etc., to install these plugins and to see how it works. Mm-hmm. But yeah, generally, all of that are now proofs of concepts. We do not have a fixed timeline for making it available in update centers. So yeah, we agree that we need to do that. and yeah, we will be working towards that. But there is no ETA.
Okay, very good. Thanks.
Yeah, so the idea that once we have something stable, yeah, we publish it as alpha releases, and yeah, we start from there. And for Jenkins core changes, I hope we merge it earlier, so that we will be able to use beta APIs like we do for other stories like Artifact Manager.
Okay. I'm asking because like those ideas seems to be very cool, and the moment I present it to my colleagues at Pragma, I'm pretty sure that will be the first question they ask. So just wanted to clarify what's the status. But yeah, I get it. I understand the answer. So thanks.
Yeah, so we have demos even now. These demos are just in flux because we change APIs. If you want, you can try there. My links are in the chat and in the meeting document. But yeah, we will continue improving them later.
I have a question for people in the call. Is people interested on these Elasticsearch and CloudWatch backends or a different one?
Yeah, what I'll start doing, we had meeting notes somewhere in our Google Doc. So let's start filling these things. Yeah.
Maybe, Jeff, that you asked the question. So are you thinking on using one of these, creating a new one, or would be interested on a new, different backend?
In terms of storage?
Yeah.
No, this is fine. You mean the Elk stack?
Yeah, Elk stack or CloudWatch or something else.
Yeah, no, we store our logs in Elk right now in AWS. So this seems like it fits perfectly.
Okay. Anyone else?
Yeah, so Alex said that he looks towards moving everything to SQL. So Alex, if you could clarify your vision, it would be great. Yeah, muted. Oh, the heat is.
Okay.
Yeah, I think in chat he said that he's looking at Postgres.
Yeah, SQL is not gonna be a great option for storing logs.
Yeah, so our main problem is that everything is pluggable. So what we could do in the current event API, at least we have this thing, so string serializable. But actually what we could do is convert it to string, so that at least you would be able to implement a kind of key value storage in SQL. So it would become more flexible. But yeah, with string serializable, I don't believe that SQL would be easy.
Well, I think you would just want a custom table definition with proper columns for all of that. I mean, I don't think in general that a storage provider would want to be given an opaque map of data. I think we would be expecting a particular set of fields, such as timestamp, message, build number, step number. That's
yeah, you would store the event object in with its data, its attributes.
Yeah, I mean, so for CloudWatch, for example, for the CloudWatch logs implementation, we are sending a JSON string to FluentD, and then CloudWatch is storing that, and it allows you to do JSON field-based queries. But but there are specific fields that are, they're called out directly in the plugin code as being meaningful, and then it's significant what those fields are on the CloudWatch side as well, because again, you could have an implementation of a client-side log browsing that's expecting certain fields to be in certain places, and you have expectations about what kinds of filter searches you can do efficiently, and things like that. So I think the same would be true of a SQL backend like Postgres. You would expect to have a table with predefined columns that you could, that would be properly indexed so that you could efficiently run a query, say on build and step, like we're doing in the CloudWatch implementation.
Yeah, right. So it would be easy as long as the only loggable object is run. But actually, we could have other implementations. So, for example, we could create a log browser or whatever for any kind of task in Jenkins. And in such case, you may have to create separate tables for each kind of loggable, which is probably doable, but it will require some work.
I'm not sure that you do. I mean, all of Jenkins logging basically uses the same task listener type interfaces. It's all basically sending text streams with console.
Right, but you will need to categorize the data. So it means that for runs, we can easily say that there is build number or so. What would we say about periodic task, for example? Or what would we say about agent connection log? So for all these types, we will need different categorization data. And this data will need to be indexed if you want to get at least some feasible performance. So I expect that it will be still some differences in SQL structures.
Well, I mean, the only difference between runs in Jenkins, so build logs, and the other things that you mentioned, or that the other things have no notion of history. So whereas builds have a numeric history sequence, and you want to record the build history at any given time for things like agent connection logs, branch reindexing, and so on, we could just omit that field, or we could set it to the timestamp of the start of the build, or to the start of the log, or something like that. But in general, those things we don't have. Jenkins doesn't provide any notion of historical log for this. It's just ongoing log.
Fortunately, but yeah, from the administrative standpoint, it may still be valuable to have access to this history.
Yeah, so you could, right? But that can also be provided pretty simply by something like starting timestamp. So, we're already storing a timestamp in the backend whenever we log a line of text. We could simply say that if you're displaying something like an agent connection log, the logic would just be apply a filter with timestamp greater than whatever you required as the start time of the agent connection. From the back end, you would see, the aggregated log from all reconnections of a given agent by name.
Yeah.
In the UI, you would see only those from the current connection.
Yeah, right. But still Go on Kafka SQL will require a lot of design. However, even for document-based storage, it may be also tricky.
I don't think it intrinsically requires any special design. I mean, you could take, we're doing for CloudWatch, it's just a set of fields, JSON fields containing flat strings. I mean, it would map directly to a table structure in SQL. But we would need to have a stable common API that we can prototype those things with as well. I'm not sure how widespread the desire for a SQL backend is.
I know at least one person who also wants to get that. Yeah, but yeah, so does anybody else have opinions about the backend? Anybody?
Sounds like not right now.
Okay, so if you have any opinions, just put it there. Yeah, so
I'm sure more will come along.
yeah, right. So what our consumers, as I said before in the presentation, we have several projects like Jenkins X and Jenkins Essentials. So they seem to be natural consumers of all this stuff. And yeah, likely we will be working with these teams in order to define how it would look like for them. And maybe we will invite them to our next sessions. Okay. So any other feedback regarding the designs?
Yeah, I think that's it for now.
Yeah, right. So as you may see, there is still a lot of work ahead. We started synchronizing base stories, and when we have a kind of stable implementation with all bits and external logging API, I will do another demo so that we see how it could be implemented in a pure implementation. Okay, yeah. We don't have so much time left. There was another item in the agenda of what would we like to discuss during the next meetings. So in addition to stories we announced in Cloud Native Special Interest Group, would you like to put something into the agenda for the next meetings? Just a second, I'll screen share again. Okay, so what do we have now? If we go to cloud-native-sig, so cloud-native-sig, here you may see that we have 3 stories in the priority list. It's log storage, it's artifact storage, which has been already released, and there is also configuration storage, which will likely start soon. I have an action item to publish some foundation designs for that. So these are our main 3 stories we have on the table now. And things mentioned by Jeff, like test storages, may also get into the list.
Yeah, I think we should add test storage for sure.
Yeah, so it's likely an action item for Carlos. So if everybody has opinions of what needs to be done by cloud-native-sig, just comment in the mailing list. So his cloud-native-sig vision and priorities. So if you want to add something to the agenda, just put it here and we will try to discuss that. I tried to provide my feedback in this blog post. So yeah, there is lots of text, but yeah, actually what I've tried to point out here, in addition to advanced status updates, that yeah, there are some other stories I would like to consider. And yeah, Jeff, you may see that actually code coverage API is also there. So I'm interested. And yeah, it also may make sense to start looking at other architecture changes. Because yeah, the end goal mentioned by Carlos when he created a SIG is to move towards things like high availability, rolling upgrades, etc. So it's not just externalizing the storage. By moving storage outside, we won't make Jenkins cloud native. So there are more stories to follow up, and we could start building a backlog of these stories and somehow prioritizing them. However, yeah, it's hard to say when we get there. Okay. So does anybody want to discuss any additional stories? Okay.
it seems like I think we've probably covered enough ground in this meeting. We're at an hour and a half.
Yeah, right.
There's a lot that's gone on here for us to sort of grok. Maybe it's this is good enough for the first meeting, and we should schedule the next one and have an agenda for that. I think this is all us kind of getting up to speed.
Yeah, right. Something I wanted to ask next is how do we organize the meetings? Because yeah, 6 are expected to have at least one meeting per month or so. But in the current state, we could do the meetings more often because we already have some history we could talk about, like artifact management, and yeah, we could continue diving into external logging because yeah, it's hard to discuss everything at a single meeting. So one of the options would be to just have weekly meetings or maybe bi-weekly meetings. So how would we approach that? Carlos, what do you think?
Carlos, if you're talking, you're muted.
Yeah.
Weekly seems too frequent to me, given the scope of stuff being discussed. But
Sorry, I got a call at the same time. You are talking about the frequency of the meetings?
Mm-hmm.
Yeah, weekly seems too much. We can either do it every month or so, or whenever we have new things to grok or people want to have an update. I can see there may be other people interested in knowing, like, when this goes live, or there is or the JEP is approved on how do I implement my own backend driver or something by plugging.
Well, it seems that there's also some open issues, a number of open issues we discussed. So it might be good to start with at least, one every other week or so.
Yeah.
To kind of move those discussions along.
Yeah, I agree. So what we could do, let's schedule, so for external logging, I would be interested to have a meeting in 2 weeks with status update and with some sync up on the core side. But if needed, we also can do intermediate meeting, but yeah, we can sync up in the chat on that. So let's schedule something in 2 weeks. For external logging.
Sounds great.
I'll send Doodle then.
Or maybe just pick this time again. Seems reasonable.
I would say
reasonable
that
the first time.
Yeah, this time is not exactly comfortable to me.
Okay.
Yeah, I would rather prefer another time.
Okay. So we'll discuss.
Yeah, I would rather propose to go through another scheduling process and define a regular time slot. Because, yeah, this time I just sent Doodle for 1 day, so that I've got not so many slots where we have overlap. But if we schedule weekly meetings, let's just have another voting and yeah, just have the entire week as options. Okay, I will do that.
Cool. All right. So, are we good for this meeting?
Yeah, I guess so.
All right.
So then I will stop the broadcast. So thanks everybody who participated in the call. If you have any follow-ups, let's discuss them in the chat or in the mailing list. And yeah, see you in 2 weeks.
Cool. Great. Thanks, Oleg.
Thanks.
Thank you.
Thanks.